Hello, I'm Miss Ginsburg with KnowAtom, and today we're going to be reading Matter in Motion. This is a student reader in Unit 1. Exploring Space with Science. Photographing Space. A telescope the size of a school bus has been circling Earth since 1990. A telescope is an instrument that helps people see objects that are too far away to see with just our eyes. This telescope is called the Hubble Space Telescope. It circles Earth from about 547 kilometers or 340 miles above Earth. It has helped scientists know more about the universe. The Hubble Space Telescope was the first telescope ever to be sent into space. Scientists have used it to observe objects in the night sky so far beyond Earth that we cannot see them from Earth. The Hubble telescope has taken many pictures of objects in space that humans had never seen before. Following a scientific process. Scientists are fascinated by the universe. Earth is just one small part of the universe. The universe holds all of the matter and energy that exists. The universe is so large that it is hard to study. Scientists use instruments such as the Hubble Space Telescope to learn more about what exists beyond Earth. Science is the search for explanations about the natural world. Because of this, asking questions is something that all scientists do. Scientists look for the causes of what they observe in the world around them. They use evidence to form conclusions that support those explanations. All knowledge learned from experiments is part of science. Science is part of a larger cycle that includes engineering, math, and technology. This cycle is called the STEM cycle. Engineers apply scientific knowledge to create new technologies that solve problems. Math is a tool that both scientists and engineers use to capture results and communicate those results to others. So here it's showing science, technology, engineering, and math are connected in the STEM cycle. Scientists use a scientific process to guide them as they answer questions about the world around them. This process provides scientists with a logical framework to work from, a question to a data-based conclusion. Scientists always begin with a question. The question helps scientists figure out exactly what they are trying to find out. Scientists have many questions they are trying to answer. One question is, how old is the universe? In order to answer that question, scientists need to answer many smaller questions. Scientists conduct many different experiments every year. Every year, the amount of scientific knowledge grows. The Hubble Space Telescope has made more than 1 million observations since first going into space. Scientists use this existing body of knowledge to research their question. For example, scientists know that the universe contains all of the stars, planets, and other kinds of matter known to exist. Scientists also believe that Earth formed about 4.5 billion years ago. After scientists have researched their question, they form a hypothesis. A hypothesis is a statement that can be proved true or false. For example, a hypothesis is the universe formed earlier than Earth formed. Scientists then write a summary of the experiment they will conduct to test their hypothesis. The summary should include the basics of the data to be collected, the variables that will be tested, and the parts of the experiment that will remain constant in each test or trial. Scientists will then list materials needed and the procedure they will follow. A procedure is like a step-by-step recipe for the experiment. A good procedure will let someone else repeat the experiment exactly. Scientists also draw a scientific diagram. They do this so anyone can use the same materials and follow the same steps to get similar results. They also want to create a record of their thinking. Scientists then conduct an experiment. An experiment is a procedure designed to test whether a hypothesis is true, false, or inconclusive. As scientists conduct experiments, they gather data. Data are numbers and observations gathered from an experiment. Scientists use different tools for gathering data. The Hubble Space Telescope has mirrors, cameras, and other instruments for gathering data. The telescope takes pictures and sends them to Earth. Scientists then download those images to study. Scientists use experiments to look for patterns in data. A pattern is something that happens in a regular and repeated way. A pattern sometimes tells scientists they have discovered a cause and effect relationship, where one event or thing is the result of the other. In order to discover a cause and effect relationship, scientists design experiments in a way that shows how changes to one thing cause something else to change in a predictable way. Scientists do this in a very specific way, with variables and constants. A variable is something you change. One kind of experiment is a controlled experiment. In a controlled experiment, there is usually one variable being tested. For example, when scientists built the Hubble Space Telescope, they wanted to test how the space environment would affect the materials that make up the telescope. The space environment was the variable. The experiment also has constants. Constants are conditions that remain the same during each trial. Scientists keep certain parts of the experiment constant so they know that only the variable that they are testing causes a change. Finally, an experiment sometimes has a control. A control receives the same constants, but it is not exposed to the variable being tested. The control captures the effect of unknown variables. For example, scientists had a control telescope on Earth. The control telescope was exposed to all of the same factors as the test telescope in the space environment. The experiment summary identifies the variables, constants, and controls. After data has been collected, scientists form a conclusion. The conclusion uses data from the experiment to explain why the hypothesis is true, false, or inconclusive. For example, data gathered from Hubble has led scientists to conclude that the universe is about 14 billion years old. Here's the Hubble Space Telescope's control center. Following a scientific process. Question. End with a question mark and do not include words such as I or because. Research. Include a minimum of 3 facts relevant to the question. Hypothesis. Write a concise statement that answers the question and can be proved true or false. Summarize experiment. Describe in 2 to 3 sentences the experiment you will do to test whether your hypothesis is true or false. Identify the variables, constants, and controls of the experiment. Variables of the experiment are changes being tested. Constants of the experiment are conditions unchanged during each trial. A control in the experiment captures the effect of unknown variables. Materials and procedure. Vertically list all materials needed for your experiment with quantities. Next, vertically list the numbered steps of your procedure. Note safety precautions. Scientific diagram. Draw a diagram of the experiment setup that is at least the size of your hand. Title it and include labels for all materials on the materials list. Data. Follow your test procedures and gather data, both observations and numbers, to determine whether the hypothesis is true, false, or inconclusive. Use proper units, title data tables, and tape it into lab notebooks. Conclusion. Use the data collected in the experiment to explain why the hypothesis is true, false, or inconclusive. Every conclusion must contain a minimum of 3 elements. 1. Restate your hypothesis. 2. Make a claim, true, false, or inconclusive. 3. Use key points of data as evidence to support and explain your claim. Matter in space. From its position above Earth, the Hubble Space Telescope makes observations of Earth, the Sun, and distant stars. Earth, the Sun, and stars are examples of matter. Matter is everything that has mass and takes up space. All matter is made up of tiny parts that are too small to be seen. These parts are called atoms. An atom is the smallest piece of matter that has the properties of an element. An element is a substance entirely made up of one kind of atom. There are 118 different kinds of elements. All matter is made up of combinations of the 118 elements. Both non-living things and living things are made up of atoms. Even though atoms make up both living and non-living things, atoms are not alive. Atoms are so tiny that we cannot see them. Just one grain of sand is made up of many millions of atoms. Think about a grapefruit. If each atom in the grapefruit were the size of a blueberry, the grapefruit would have to be the size of Earth. There are so many atoms in just one grapefruit that they are impossible to count. Imagine having to fill up the entire planet with blueberries. That's about how many atoms are in one grapefruit. Atoms themselves are made up of smaller particles called protons, neutrons, and electrons. These smaller particles are much smaller than the atom itself. Because atoms are so tiny, scientists use scale to better understand the size of an atom, its smaller parts, and how it relates to everyday substances. Scale is the size, extent, or importance, or magnitude, of something relative to something else. For example, the protons and neutrons group together in the atom's core, called the nucleus. If the atom is the size of a blueberry and you open the blueberry up, the nucleus would be too small to see. If you were to make the blueberry the size of a football field, you would just be able to see the nucleus. It would be the size of a small marble. The nucleus holds all of the atom's protons and neutrons. Most of the atom is filled with empty space. The electrons are much smaller than the protons and the neutrons. They are in constant motion around the nucleus. However, there are huge amounts of space between each of the electrons and between the electrons and the nucleus. Forming matter. All of the matter that exists, including stars, planets, and all the other stuff in the universe, is made up of combinations of the 118 different kinds of elements. There are so many different kinds of matter because atoms are like Lego blocks. They can fit together with other atoms to form bigger pieces of matter. Whenever two or more atoms join together, they create a molecule. Molecules are formed as a result of a chemical reaction between two or more atoms. In a chemical reaction, the atoms of the original substances are rearranged to form new substances that have different properties from the original substance. There are a couple of clues to look for to determine whether a chemical reaction has occurred. For example, a change in color or odor can be a sign that a chemical reaction has taken place. Also, if a gas forms when two different substances are mixed together, a chemical reaction has occurred. So here it's showing that the rust is the result of a chemical reaction. It forms when the element iron combines with oxygen. Conserving matter. Chemical reactions occur when two or more atoms interact. The effect of this interaction is that the atoms are rearranged to form new molecules. However, the total number of atoms does not change in a chemical reaction. The mass of any one element at the beginning of a reaction will equal the mass of that same element at the end of the reaction. This is called the conservation of matter. It states that atoms are never created or destroyed during a chemical reaction. They are rearranged to form new substances. For scientists to measure that matter has been conserved, they must conduct the chemical reaction in a closed system. In a closed system, matter is prevented from being added or removed from the system. In contrast, in an open system, some of the mass is transferred to the environment, which is impossible to measure. Matter has different properties depending on the number and kind of atoms that make it up. A property is an observable or measurable characteristic of matter. Properties help scientists classify and describe different kinds of matter. Properties include texture, flexibility, color, mass, volume, temperature, and odor. For example, scientists can use color to describe an object. Color is an observable property. From space, Earth is green and brown from the land, blue from the oceans, and white from the ice caps and clouds. Properties can also be measurable. Measurements are an important part of science. Scientists use the metric system, which communicates measurements of mass and distance in units such as grams and meters. Mass is an example of a measurable property. Mass is a measure of the amount of matter that makes up an object. It increases as the number and size of atoms increase in an object. It is measured in grams. Whether or not a substance is a solid, liquid, or gas is another property of matter. This is called state of matter. Earth's atmosphere is made up of a mixture of gases. Gases are different from solids or liquids because of the amount of heat present. The atoms in gases are far apart and move with a lot of energy. As a result, a gas takes the shape of whatever it is in. It will spread out to fill all the space it is in, no matter how big the space is. In liquids, there is less available heat than in gases. The atoms in a liquid are close together, but can slide past one another. This is why liquids flow, taking the shape of their container. The water in oceans is an example of liquid water. Solids have the least amount of heat. They do not have enough energy to move past one another. As a result, solids hold their shape because the atoms that make them are packed tightly together. They hold their own shape until something changes them by force. Earth's land is an example of a solid. Remember that cause and effect describes the relationship between events or things, where one is the result of the other. For example, when the right amount of heat is added or taken away, it causes a substance to change state. When a substance changes from one state to another, it is a physical change. In a physical change, the atoms and molecules that make up the substance do not change. For example, if you leave an ice cream cone outside on a hot summer day, it will melt. The solid ice cream will gain heat, causing it to turn into a liquid. However, the ice cream will not change its chemical structure. It will still have the same chemical properties. It can also turn back into a solid when enough heat is removed. Identifying properties of matter. So we're going to go over the property, what it is, and if it's observable or measurable. So a qualitative property are those that can be observed and described, and quantitative properties are those that can be measured. So color. How matter reflects or absorbs light. Example, red, yellow, blue. This is observable or qualitative. Mass, a measure of the amount of matter that makes up an object. Measurable in grams or kilograms with a scale. This is quantitative. Shape, the form of an object. Example, circle, square, rectangle. This is observable or qualitative. State of matter, the different forms of matter depending on the amount of heat present. Example, solid, liquid, or gas. This is observable or qualitative. Temperature, a measure of how fast molecules are moving. Measurable in degrees Celsius or with a thermometer. Quantitative. Texture, the feel of a substance. Example, rough, smooth, soft, hard. This is observable or qualitative. Volume, a measure of how much space an object or substance takes up. Measurable in cubic meters for solids with a ruler, liters, or milliliters for liquids. This is quantitative. Scale in the universe. Looking back in time. The Hubble Space Telescope allows scientists to look back in time. This means they can study the history of the universe. This is possible because when you look at the stars in the night sky, you are seeing light that is thousands or millions of years old. This light has traveled billions of miles through space to reach your eyes. The farther away an object is, the longer its light takes to reach you. When you look at an object across the room, you actually see it as it was a few billionths of a second ago. Stars are so far away that it takes a very long time for their light to reach us. For example, the Hubble Space Telescope has taken pictures of a large cluster of stars that is 100 million light years away. The distant stars are so far away that the images are actually from 100 million years ago. At the time that light left those stars, dinosaurs still roamed Earth. Scaling the universe. The universe is full of mostly empty space. Millions of miles separate Earth from other objects in the universe. The universe is so immense that when scientists talk about distances, they often use scale models. Scale models are useful for scientists who want to understand how the various parts of the universe interact. For example, scientists can use a scale model to observe the different parts that make up the universe. Earth is part of the Milky Way galaxy. A galaxy is a large cluster of stars. The Milky Way galaxy is shaped like a thick pancake. It contains billions of stars. There are hundreds of billions of galaxies in the universe. So here's the solar system, which is within the Milky Way galaxy, which is within the universe. Scaling distance. Earth is part of a solar system in the Milky Way galaxy. A solar system is a collection of planets and other objects that orbit a star. A planet is a body that orbits or travels in a circle around the sun, is massive enough for its own gravity to make it round, and has cleared out smaller objects around its orbit. The sun is the center of our solar system. The sun is a star orbited by planets. There are 8 known planets in our solar system. The sun is much closer to Earth than any other star. In Earth terms, however, it is still very far away. It is 150 million kilometers, or 93 million miles away from Earth. At this distance, it takes sunlight 8 minutes to travel from the sun's surface to Earth. Neptune, the farthest planet from the sun, is much farther than Earth. It is 4.5 billion kilometers, or 2.8 billion miles from the sun. Scaling size. Scale is also important for understanding how the masses of different objects in the universe compare to each other. For example, as far as stars go, our sun is an average-sized star. Other stars are much more massive than our sun. However, it seems so much larger and brighter than any other star because it is so much closer to Earth than any other star. The sun is the most massive object in our solar system. It is so massive that more than 1 million Earths could fit inside the sun. Its diameter is 1.4 million kilometers, or 865,000 miles wide. In comparison, Earth's diameter is 12,742 kilometers, or 7,918 miles. In other words, if the sun were the size of a typical front door, Earth would be about the size of a nickel. Jupiter, the largest planet in our solar system, would be the size of a basketball. Mercury, the smallest planet, would be the size of a pea. So here's a model that shows the relative sizes of the 8 planets. Mass and gravity. The sun is made up mostly of the elements hydrogen and helium. It is a hot ball of gas that produces its own light through chemical reactions. It is so massive compared to the other objects in our solar system that its gravity holds the entire system in place. Gravity is a force of attraction between all matter. Gravity is what keeps you on Earth. It is also what holds the solar system together. Gravity is a result of an object's mass. The more massive an object is, the more its gravity will pull on other objects. The sun is so massive that its gravity reaches beyond the 8 planets of our solar system, pulling every planet toward it. When an object is much more massive than any other object near it, its gravity will pull on the other objects and cause them to move. This gravitational pull is why the planets orbit the sun. So the sun's gravity holds the 8 planets in orbit. Earth's gravity. The force of gravity becomes weaker as the distance between 2 objects increases. The sun is much more massive than Earth, but it is also much farther away. This is why here on Earth, you always experience the pull of Earth's gravity. All matter has gravity, even the matter that makes up people. The reason a person doesn't noticeably attract nearby objects is because more massive objects have more gravity. Earth's gravity pulls on all objects on or near Earth's surface because Earth is so massive. Earth's gravity keeps you from floating off into space. It is also why things thrown in the air fall back to the ground. Earth's gravity pulls all objects near Earth's surface downward. The gravitational force exerted on an object by a planet or moon is called weight. It is measured in newtons. Here on Earth, weight is calculated by multiplying the object's mass by the force of Earth's gravity. The pull of gravity is nearly identical everywhere on Earth. Non-scientists often think that an object's weight is the same as its mass. The two are related because an object's weight depends on its mass. However, weight also depends on the force of gravity. When astronauts travel to the moon, their mass doesn't change, but their weight does. This is because the moon is much less massive than Earth is, so its gravitational force isn't as strong as Earth's. The moon has a diameter of 3,476 kilometers, or 2,159 miles. It is about 1/4 the size of Earth. If Earth were the size of a basketball, the moon would be roughly the size of a tennis ball. The moon orbits Earth for the same reason that Earth orbits the sun. The pull of Earth's gravity keeps it, along with the Hubble Space Telescope, in orbit around it. Patterns on Earth. Gazing into space. Long before the Hubble Space Telescope was launched into space, people used to watch the sky. They noticed patterns in how the sun, stars, and planets and moon moved across the sky over a day, a month, and a year. From Earth, it appears as though our planet stays still, while the sun, moon, and stars travel around it. The sun appears to rise in the east and set in the west. The moon seems to travel across the night sky, and the stars appear in different places in the night sky depending on the time of year. Scientists now know that Earth is in constant motion. Earth and the other planets orbit the sun, while the moon orbits Earth. At the same time, Earth is also rotating. This means it spins like a top. Day and night. Earth rotates on an imaginary line that goes from the North Pole to the South Pole. This imaginary line is called an axis. Earth rotates very quickly. Earth completely rotates around its axis about once every 23 hours and 56 minutes, one Earth day. The reason we don't feel like we're speeding through air is similar to how it can feel in an airplane, like the plane isn't moving. Gravity holds us all onto the planet, and so we rotate with it. As Earth rotates, part of the planet gets light and then dark. The sun always shines, but its light only hits 1/2 of Earth at a time. This is why we have day and night. The patterns in how the sun, stars, planets, and moon move across the sky are caused by Earth's movement. All of these bodies appear to rise in the east and set in the west over one day because of Earth's rotation. Telling time with shadows. During the day, the sun appears to move across the sky. At dawn, the sun appears close to the ground in the east. As hours pass, it moves upward. By noon, the sun appears directly overhead. In the evening, the sun appears close to the ground again, this time in the west. At night, the sun appears to disappear. Long ago, people noticed that as the sun rises in the east, it casts shadows that change throughout a day. Shadows are dark shapes created when an object blocks light. The length and direction of the shadow depend on how low or high the sun is in the sky. When the sun shines down from directly above you, your head is the only part of your body blocking the sunlight. As a result, there is very little shadow. In the middle of the day, around lunchtime, your shadow will become very small. It might even disappear. In contrast, your shadow will be the largest when the sun is near the horizon. This is because your body blocks more light. Changing seasons. Shadows also change throughout the year. Shadows are much longer during the winter months than during the summer months. Shadows change throughout the year because the sun appears in the sky at different heights depending on a season. A season is a period of time characterized by specific weather patterns and by the length of day and night. In the summer, the sun appears high in the sky. In the winter, the sun appears much lower in the sky. We now know that the sun appears to be in a different location throughout the year because of Earth's position in the solar system relative to the sun. As Earth moves around the sun, it is tilted 23.5 degrees on its axis. Because of Earth's tilt, the northern and southern hemispheres each receive different amounts of sunlight throughout the year. For half of the year, the northern hemisphere is tilted toward the sun. The sun appears to be high in the sky, so the sun's rays shine more directly onto Earth at a higher angle. When this happens, shadows are smaller and temperatures are warmer. At the same time that it is summer in the northern hemisphere, it is winter in the southern hemisphere. This is because the southern hemisphere is tilted away from the sun. The sun is lower in the sky, causing the sun's rays to hit Earth at a lower angle. This causes the sun's rays to spread out over more space, causing longer shadows. It also makes temperatures cooler. For the other half of the year, the northern hemisphere is tilted away from the sun, and the southern hemisphere is tilted toward the sun. Now it is winter in the north and summer in the south. Changing constellations. The sun is not the only object that appears to move in the sky. Long before we had calendars and clocks, the movement of the stars was another important sign of the changing seasons. Each night, a few stars appear in the east that weren't there the night before because Earth has moved slightly in its orbit. People named patterns in stars based on famous animals, objects, or people. These patterns are called constellations. Perhaps the best known constellation is Ursa Major, which looks like a big bear. The tail and back of the bear are also the 7 bright stars that make up the Big Dipper. Other constellations include the Summer Triangle and Orion. When the Summer Triangle is visible, spring and summer are near. When the constellation Orion is fully visible, the cold of winter is coming. Unlike constellations such as the Summer Triangle and Orion, some stars can be seen in the sky all year. For example, Polaris, or the North Star, is an example of a star that doesn't appear to move from the northern hemisphere because it lies almost exactly above Earth's northern axis. Why does the moon change? People have long used the movement of the moon to mark the passage of time. Within a month, the part of the moon that we see from Earth changes from a full white disk in the sky to a small silver and then back to a small sliver and then back to a full white disk. These changes are called phases. They occur because of the changing positions of the moon, Earth, and the sun as the moon orbits Earth. It takes the moon 29.5 days to completely orbit Earth once, about equal to 1 month on Earth. The moon doesn't emit its own light. Instead, we see the moon because the sun shines on it, lighting it up for us. Exactly half of the moon is always in sunlight, in the same way that half of Earth is always in sunlight. The same side of the moon always faces Earth, but the part of the moon that we see depends on where the moon is in its orbit around Earth. Sometimes we see parts of both the sunlit portion and the shadowed portion. Wow, I learned a lot reading Matter in Motion. I hope that you learned a lot too. I'll see you tomorrow for the next one. Bye!